Take the thing down.
So transforming it means that it's going to be shifted, stretched, all that kind of stuff. You did it in Algebra 2 with quadratics, with parabolas a lot. These ones will just have the curve. So this A that's in front will tell you the change in amplitude. Remember, amplitude is the height up to the peak of the graph and down to the min. The B value will, I want to say that this will affect the period. That'll affect the period. It's not the actual period. You'll be using that B value to find out what the period is. The period is how long until the function starts repeating itself. So it's like how long until it gets back to where it was. So you remember the sine and the cosine graph essentially look like this. Okay. The C value is a phase shift, which will be left or right. And the D value will be a vertical shift up or down. And then the cosine graph, the variables are the same, so I'm not going to rewrite them, but remember the difference between the sine and the cosine graph is that the sine graph starts at 0, 0. It goes up to 1, down to 0, down to -1, and back up. So that's like the sine function, which we're going to graph it right below, actually, I think. The cosine function, do you remember what was different about the cosine function? It starts at 1. Then it goes down to 0, then to -1, then back up to 0, and back up to 1. So the main difference is, again, I call them like the starting points where they cross the y-axis. And then from there, you're just kind of following a pattern. All right, so on the front, we're going to do all sine graphs, and on the back, we'll do all cosines. So question 1A, and this is what your quiz will look like. I'll have you do the parent function first. And then what you can do is you can use the parent function to, like, do all the other ones to kind of modify them. So the regular sine graph of x starts at 0, goes to 1, goes back down to 0, down to -1, and up to 0. I would memorize just those points. And you can probably just go backwards and kind of do the opposite. So this will go down, back to the x-axis, up to 1, and back down. And then again, we do sketch a curve the best that we can. Not triangles or segments. That needs to be rounded. Okay, so again, this is our parent function. You want to memorize this one. You really don't have to because you'll have a graphing calculator, so you could use your graphing calculator to do it for you. But all right, the next one is a transformation. So this negative, does anyone know what the negative out front would do? It's almost like a -1. Yes, this will be a reflection across the x-axis. So these points here, these will not get reflected because those are on the x-axis. So those, I'll call those like mid-level points. But the max will become a min, and the min will become a max. So it just kind of flips across the x-axis. So again, the middle point stays 0, 0. But instead of going up to 1, it'll go down to -1. Back to 0. This point here is going to get reflected up. So I'll plot that over here. And then our last one, again, is a mid-level point, so it just stays on that x-axis. Now on the other side, you just want to continue the pattern so that it kind of goes as it should. So this would go up, and you could do each point actually reflected. Back down to your midpoint, down to -1, 0. If when you connect these, you can see that it doesn't actually oscillate like a wave, then you may have made an error in your points. The next one has a 3 in the front. Okay, and you'll see that I bring my parent function along like up here so we can kind of reference it. So you're always referencing that parent function. So this is changing your A value, which is the amplitude. Okay. Now again, the mid-level points, which are not mins or maxes, those don't get modified at all in the sine curve. The only thing that's changing is the height of the wave. So instead of going to 1, we'll actually go to 3. So we will still start at 0, 0, the origin. Normally the sine curve goes up to 1, 1. This time we're going to go up to 1, well really pi over 2, 3. Back down to 0. Normally the curve then goes to -1. This time we'll go to -3. And back up to 0. The other side, you just kind of do the reverse.
So for the sine function, we'll always start at 0.
Unless we have a shift left or right. But yes. So this one, as you can see, is shifting up 1. So like we'll take where we would normally start, and we'll shift that point up 1. But we'll look at that. If there's no shifts, though, this one again will go down to -3, 0, +3. Just kind of copying that pattern. D, we have a +1. Now notice this is, and if you can look back up at the top, there was a plus inside the parentheses, and then there's also a plus outside. This would be outside because there's no parentheses. So this would be a vertical shift up. So you're literally taking every point from the parent function and shifting it up 1 unit. So my parent function originally started at 0, 0. I'm going to shift that up 1 unit. So my starting point is going to be at 0, 1. And I always usually do the positive quadrant. The next one started at 1. I'm going to shift that up 1 unit. So that'll actually go to 2. At pi, it was at 0. Shift that up 1 unit. That goes to 1. That's why I always put the parent function on the same page so you can reference it as you go. At 3 pi over 2, it was at -1. Shift that up 1 unit. It goes to 0. And then back to 1. And then usually that's enough points to be able to figure out the pattern. But if not, go and do the negative side also. So once you sketch this, and some students actually like to put like a dotted line where the mid-level is. You're welcome to do that if you like. And then those points again are just kind of your middle. You go down, up, up, down. But sometimes that can help you to understand that those are mid-level points. So this is going to come down, back up, and down. And there's one more on this page that has multiple things going on, and that will have a amplitude change and a shift. It's looking like our quiz is going to be Monday now. We're running out of time. So I'm going to have to do the back of the notes tomorrow. So the amplitude is being changed to 2, which is changing your max and your mins. Not the middle level points, but your max and mins will become 2 units away from the others. This -1 is telling me to shift it down 1 unit. Now, maybe put in our notes that the amplitude only affects the max and min. So whenever you're doing these from the parent function, the mid-level points don't get changed 2 units. They will get shifted, but they will not get an amplitude change. So again, I usually start at this one, this point, and I like take and hold my pencil where it would normally start. It should start at 0, 0. It's not a max or a min, so I'm not going to do anything with the 2, but I will shift it down 1 unit and put a point. All right, the next point normally goes to pi over 2, 1. So I take and I hold my pencil, pi over 2 over 1. I need to change the amplitude to 2. So normally it went up to 1, and amplitude would change that up to 2. You don't move it up 2 spaces, you just almost multiply 1 by 2 to get 2. And then I'm going to shift it down 1 space. Now some students will think, oh, well, I know if it's an amplitude of 2, I'm going up 2 spaces. That's another way to think of it too, because these are your mid-level points. And if you want, you can draw a dashed line in where the mid-level is, and then just do your mins and maxes. Okay, the next point is normally at 0, pi, 0. So hold your pencil at pi, 0, mid-level point. Amplitude does not affect that. We do have to shift it down 1. And if you draw in this dotted line, you'll see that it lands right where the other one was. Okay, the next point was normally 3 pi over 2 comma negative 1. This one, the amplitude is changing to be 2. So I'm going to move it down to negative 2. And I'm shifting down 1 from there. So it should be down at negative 3. Now, if you did this correctly, you should notice that there's 2 units between the mid-level and the min. The amplitude has to be 2, so they have to be 2 spaces away. Others of you will think of this like a pattern. You'll go up 2, down 2, down 2, up 2. And you won't actually do piece by piece, but everyone's a little bit different. And then the last one, pi over 2, would be a mid-level point starting there. We shift it down 1 to negative 1. On the other side, we're just going to do the reverse. So instead of going up, we'll go down 2 to negative 3, back to our mid-level, which is at negative 1, up to 1, because that's 2 spaces above, and then back down to 0. All right. We'll save the cosine graph for tomorrow then. Probably another delay, so. So let's see what homework questions we are going to do then, because you're not going to do all of them, since you haven't learned the cosine graph yet.
Can I do them if I know?
Why don't you just do the front? Oh, no, you can do the front. Why don't you just do anyone that has a sine function in it? Okay. So 3, 6, 9, 13, 15, 21, 24, 25, 31, and 35. Enough on that next page. So if you see a cosine, don't do it. See a sine, do it. Okay. And tomorrow we'll look at that cosine graph. Those of you that have early release, you can leave at